recording is on. If you guys have any questions, be my guest at any moment to interrupt. Now,
So
yes,
once we open the new project, should we select any checkboxes there?
no, not at all. So
Okay.
when you create a new project, it actually allows you to create a lot of different things, right?
Mm-hmm.
Eventually, you'll have to do some web stuff. Anyway, these are all different things. For now, for us, we're just gonna use the Java regular basics. Okay. If you ever make a web server and whatnot, you'll go to Java Enterprises, and each one of them is for different things. Okay. So for now, just make sure you have selected Java at the top left, and just keep pressing
Mm-hmm.
next. Give it a good project name. Make sure the
Okay.
location is somewhere you understand where it is. Uh,
Mm-hmm.
because when you submit a project or an assignment, it's not one file like you saw in C++. You need to submit a lot of things. Okay, so this is really important.
Okay. Thank you.
No problem. When you have that done, you should see something similar to this. Let me go on presentation mode. Give me 1 second. Okay, there we go. So on the left side, you should see something project-wise. You'll see three things here. Really, we're gonna ignore everything else except for the name of our project, which is a folder. And inside there, you'll have one folder which is .idea. This is files, or let's say temporary files for IntelliJ, the IDE we're using. Same thing goes for the IML. You could again ignore all of this. If you're using a different IDE such as Eclipse or NetBeans, they'll have something similar with their own specific files. If you want to bring in a project from one IDE to the next, it's perfectly fine. The only thing that really matters is the source file that we see here, the source folder, SRC. And I'm going to show you a couple neat tricks here to make our lives easier. If you ever want to go into a specific file or folder, you could right click on it and then you go show and explore. And what it's going to do is going to open Explorer at that exact location. So if we look, I'm directly in my project at that folder, and here's my source, which is empty. So if you were to submit something to me, you would go to Idea Projects, and you would grab this. If you either use 7-zip, make it a .zip compressed file, or you could do a send to compressed zip folder, right? And you would submit this to me. As we are inside Google Drive, you could directly just go ahead and drag that folder and drop it in, and that's fine too. Either way works for me. Okay? You figure it out. Now inside that, what we want to do is on the source folder, sorry, we want to right click, new Java class. Okay, one more time, right click, new Java class. There is something called packages, but for now we're going to ignore it. So we want to create a new Java class, and we want to call it main. And this is really important because, as you learn in C++, there could only be one entry point to your application. Otherwise, the computer is going to be confused. It's going to break, right? This is really important. You got to remember that the computer is really stupid. So it can't make decisions without what you tell it to. I hope you guys can see. I'm gonna close my side panel. If ever you want it back, you just do project and it should show you everything. I don't need it, so I'm gonna bring it out. So when we start out, we see something like this, public class main. We're gonna talk about classes in a bit. What I'm gonna do in this session is I'm gonna go over every little bits and pieces. If I'm going too fast, please either raise your hand so I'll see it on Zoom and I'll stop, or just tell me, hey, can you slow down or can you repeat a part, right? Don't. One thing is to not say your questions, and everything's gonna get more confusing over the time. So take this session as a good time to review. If you have questions, let me know. Especially since OOP is what's required to start this class, not what we're going to teach in this class, all right? Even though I'm going to do it. actually, before we get started, well, actually, we're gonna do it at the same time. There's two types of comment. Sorry about that. My computer is really messing up. I need to upgrade it, update it, whatever it is. Okay, so there's a couple things we need to know. So the first thing is commenting is the same thing as C++. You have the inline comments, which is anything after this will be a comment, and you have the block comment, which is /*, right? A couple things to note is your main goal is to make sure that our main goal as junior level, entry level, is to make sure that we have a readable code. And this is really important. Readable code, you'll see it, we're gonna do it. So I'm gonna be grading you on this because a lot of times you might be really good in programming, but your code is not readable by any of your teammates. That will make you, they won't give you the job for it, right? So variable names or good function names, etc., they have to be self-explanatory, and this is really important. Okay, so our first goal is to have readable code, and our second goal is to make separation of concern. What this means is our function is only going to do what it's supposed to do and nothing else. Our variables are only going to take care of one thing and nothing else. Our classes are only going to take care of what it's supposed to do and nothing else. And this is really important. And these two things are your goals for entry-level programming. Goals. Okay? Again, the coding parts we're gonna learn, and obviously part of this is making sure to master OOP basics, foundation. Okay, obviously this is part of it. Okay, but if you can't do it good or readable, or you could always use a hammer, but if you bang inside the wall nonstop, you're gonna make a lot of damages and whatnot, right? Doesn't mean you know how to properly use it. We want to make sure we understand OOP and properly use it. So these two goals are really important. Okay, let's get started. So because it's OOP, everything...
Excuse me, sir.
Yes.
Sir, I'm a complete beginner in Java. So do I need to have any prior knowledge before I understand OOPs, or is it okay?
So I'm going to go through from the basics to OOP. This is what I'm aiming for. Knowing any programming language, the basics is all the same. Okay, the syntax might be a bit different, and we'll talk about the syntax. Stop me at any moment if something doesn't make sense, okay? So, first thing we need to note that because Java is a OOP language, a way that's been designed, everything needs to be inside these public classes, okay? We're going to talk about these a bit later as we go along. And by inside, I mean they have to be inside these curly braces. If they're not inside these curly braces, if they're not in here, it will not work. So if you put it outside as in here, it will break, okay? Everything must be between those two curly braces. You see, they encapsulate whatever's inside. Okay, so that's the first important thing. Second important thing is we need to create the entry point for our application. Eventually, we're going to have a lot of classes inside our project, right? So far, we only have one main class. But when we get more than this, or when we get a lot of functions and etc., we need to somehow let the program, let the computer know where does our application start. Why? Because the computer is really stupid, could only do one line at a time, and it needs to know where to start. So to do this, we need to do something called a void main. right? Our entry function. Inside this IDE, you could just type in main and it will automatically do it for you. You'll notice I'm going to tell you not to memorize things too much, but make sure to understand it. Understanding is 100,000 times better than memorizing words that doesn't make sense to you. And it's much harder for no reason. So when you type in main, I'm just going to do it one more time, should give you like this little thing. It's going to give you the main method declaration, which is basically a function, okay? Actually, you know what? I'm going to put some words here too. So terms. So in this case, this is a reserved keyword. So reserved keywords, basically you can't have that as a variable name, as a function name, etc. other than man, what the hell is going on? Sorry, again, I really don't know what's going on. So these are reserved keywords, so you can't use it for anything else. If you did this correctly, you'll notice there's a play button beside it. And if we run this, so we're running this main application, you'll notice it's not going to do anything after it compiled it. All right, we'll talk about that in a second. So you'll notice that in this case, this is called a function. Actually, we'll put the terms here and we'll make it better and so forth, so on. So there's the term function that you heard, and sometimes this word is also going to be used, which is a method. They both kind of mean the same thing. Inside Java, they mean the same thing. It basically means a function, a method, so an action. Actually, a better term, synonym, would be an action. Something to do when it's called, right? So in this case, it's going to start our application. It's going to run everything. It's an action that's going to be done. Why is there two terms, function and method? Well, in Java, they both mean the same thing. But in C++, a function and a method, this is where they differ. A method belongs to an object, a class. A function does not belong to a method or a class. Okay? Don't get confused by this. Just remember that they basically mean the same thing, and most people don't know the difference, so they're going to use it interchangeably. It's fine. Just remember that if I say method or function, you should still understand that it's something like this. Okay? We'll come back and explain more about how a method works in a bit, but if you notice, it's the same exact thing as your C++ course. So our void main, or this part, is our entry point to our application. And we've got to also remember that our application, again, well, not our application, but the computer is super stupid. So the only thing it could do is to come in here and run our stuff one line at a time. So it can't make decisions for us. It can't do anything that we don't tell it to do. So anything we say inside these curly braces, and it has to be inside these curly braces, it will do those parts. All right? Now, based on where you are, if you go on a higher level language, you'll notice we don't need these curlies. We could do something more English, but again, more restrictions. And now if you go in something more free or more power, like C++, you'll notice the syntax becomes more weirder. It becomes more computerized rather than becoming more English, more readable. Okay, and again, our main goal right now is readability. Cool? So again, we don't have much stuff going on here. You'll notice, so this is a reserved keyword. You'll notice there is a parameter in here. We'll come back to it in a second. When we talk about functions, we'll come back, okay? So don't stress over this. We'll come back to this in a moment. So first thing first, inside C++, you used to print to the console. To do that, you did something with cout, and you pushed it towards it. Inside Java, and again, different languages, it'll be a different term. What we need to do is this call to system.out. So we're system output, whatever the output is. In this case, it would be the console. And we're going to do one of these types of prints. You'll notice there's a lot of them. which is function overloading. We'll come back to it. So let's start doing a normal print. This is a function again that we're calling this time. Well, we're gonna come back to functions in a bit. And inside there, I'm gonna say Reza is the best. So I could bring my ego a bit up. If you guys say this 5 times a day, you'll be happy. So now when I run my application, you'll notice inside the console, Reza is the best is gonna be shown. You can also write.
Hello.
Yes.
Sir, actually, I made a little application of like Hello World,
Yeah.
but in my IntelliJ, it's not showing me option to run. It's blacked out.
So do you see a little play button?
No, sir. So it's blacked out.
If it's blacked out, there might be a couple stuff, such as you didn't do your project, you didn't put that main inside source.
Oh,
If you share your screen, I could kind of understand this better.
1 sec, sir.
So you'll notice you're gonna get a lot of errors over time. I suggest that you read what those errors are, or see other people's errors, so that when it does happen to you, you'll know how to handle it. And this is one of the key things you need to be able to do, because a lot of this is gonna come down to being debugging. So I'm just waiting to see his screen. How do I see screen? I don't see your screen, but I note you have shared. Can you guys see his screen?
No, sir.
I'm gonna pause my share to see. Let's stop my share for a second. Okay, there we go. Now we see yours. Okay, so
He didn't make any configuration.
any configuration? What do you mean? Ah, yes. Okay, so you didn't. Did you download the JDK? I can't hear you, by the way, Harmanpreet.
In class should be main maybe.
No, Harmanpreet, did you download the JDK you need for this? If at the top right, if you notice, there's this little, this 3 blue dots. Can you click on that? Top right. Top right. Yeah, the blue 3 blue dots. Go right. Yeah, that one. Click on that. Okay, you have that. That's perfectly fine. Press OK. Can you put your mouse over the string why it's giving you an error? What's going on? Okay, at the top, click Add Configuration. Let's see if there's something missing. Top right again. A bit left. Not that. Add configuration. A bit left. Left. Left.
It's written there, add configuration. Yeah, that one.
Ooh, okay. Click the plus button. And click on. Actually, you know what? Let's do something else. Let's not fix this way. Can you close this for a second and just do File, New Project, please? new project. Java is selected, press next. Next. Give it a good name. Press finish. This window. So for some reason, I don't know why it didn't configure your thing. Inside the source, right click, new Java class. I would usually like to call this main, so we know that's the entry point. Press enter. Type in main, yeah. And it works now. I don't know if you did anything differently, but it should be fine now. Okay? So add in the system.outprint hello world and try it out. And I'm just gonna let him try it once. Up. I hope everyone else is okay. Okay, there we go. So let's move on. Let me share my screen again. I hope everyone sees. Okay, so the system.outprint is their way of printing to the screen in Java. There's gonna be other ways, but for now this is the built-in that's easily accessible, and this is fine for what we're gonna do. There's actually two of these functions that we need. One is system.outprint. Actually, let me go back on presentation. Sorry. If I'm not on presentation or you can't see, let me know. So the first one is system.outprint, and the second one is, if you type in, by the way, if you type in SOUT, you could have the shortcut for that. Right? So if I type in SOUT and I press enter, I don't have to type in the whole system.out println. Now notice that there is a print and there's a println. Println stands for print line. So what it would do is it would print whatever you did and then bring the cursor to the next line. So if I do hello world and then Reza, you'll notice that Reza is going to be at the end of hello world. Bring this to the other screen. So you'll notice hello world, then Reza is printed, and then the cursor is brought to the next line and it's left there. So now if I go ahead and I do, let's say, other stuff, you'll notice that other stuff is going to be on the new line while Reza is still at the end of this. So that println is at the end just to go and do something like this, end line, right? And you'll notice that inside this case, because we're a higher level language, we can't really do this stream type of thing. We could do it if we go a bit funky, but we're not. So it's mostly calling functions again. These are built-in static functions. We'll talk about those in a second. So knowing how to print to the screen, this is going to be important. So make sure to reserve those somewhere to make sure you could do it and so forth. So I'm going to keep the hello world. I'm going to put println here as well, and shortcut is SOUT. Okay, so the IDE will autofill it for you. I try not to memorize things, but you'll notice as you use it more often and often, it's going to get memorized by itself. So this is a cool thing. Now, second thing we need to do is to be able to store values and come back to it and manipulate it. So to do this, we need to create variables. You got to understand that computer, again, is really stupid. So variables is a way for it to create a storage point. Actually, I can't draw it because I don't have my tablet to draw, but how would be a good, I would really recommend you guys check out that video I made. Actually, where is that? There we go. Inside this video, Really sorry, but it's done in paint, so it's going to be really ugly. But I tried to explain to you how the system works underneath. How does your computer works, which is with electricity, and they figured out that we could actually store those electricity values into these things we call bits. 1 for being there's electricity, 0 for it being no electricity. And by doing this, they could hold on to data. So we need to specify how much space it requires. And this is why we need to know the type, okay? So if we have something like an int, which could store numbers, positive or negative, whole numbers. So let's say age. This has a maximum size of 4 bytes, right? And each byte is 8 bits. If you watch the video, I explain a bit further why this is important, because this also defines this amount age could go up to. So there's a fine limit of how big this number can be. Or you notice it's giving me an error, right? And this is what's so good about IDEs, it can give you values. So based on that, if our number is too big, we need to determine what the type should be, because it reserved that space inside the memory. And a good example of understanding variables and why we need to figure out the correct type is, think about when you're moving and you're going to a different apartment, a house, whatever it is. And you have a box for your TV screen. Now notice that the TVs and your monitors or your laptop is usually this wide but flat device or hardware. Now that would easily enter into a bag or into a flat box. But if you try to put in the same box a chair, well, it doesn't work. If you try to put in the same box let's say water, well, again, it doesn't work. It will start leaking and whatnot. It's the same thing for the computer. It needs to determine what the boxes are going to be. This is your variables. And when you specify the box size, you cannot be changed, because it cannot just move things around. Now, if you go in a higher level language, you don't need to really mention the types and so on, and you'll notice in the newer Javas, you don't need to mention it. But it's important to understand the types, because sometimes this auto figuring out things is not what we want. Sometimes you'll be developing for, let's say, devices that have limited amount of memory or limited space or whatever, and you need to specify. You're gonna say, well, our computers are super strong, so why do we even care? Well, if you look inside your phone as an example, you have a lot of apps in there. And usually when your phone gets full with images or text messages, you don't go ahead and delete images or texts from your friends. These are important memory. You would go delete the application, which is the biggest inside your phone. And this is why Google, Microsoft, and any company really, they would pay you a lot of money to make sure that their system is optimized to the max. Those smaller companies that don't care about this, well, they're small for a big reason, right? So you gotta understand that understanding the type is important, and how big it could be is also important. So how it stores the memory, okay? And this you'll understand more and more over time. But for us, a variable is a way for us to store data to be reused at any moment, right? And this is important because if you don't store it inside a variable, again, the computer's too stupid to figure out, hey, I need to keep that for the next thing I'm doing. Okay, it cannot figure out what you're thinking or what you want it to do. So we need to specify if we need to hold on to a value at some point, and to these things we call variables. And a variable is usually a type, the variable name, and initialized to a value. You don't want to use the default values. Even though they come with a default value, it's unpredictable sometimes depending on the OS, the system, the hardware. Okay, so you got to be a bit careful with this. So there's a lot of different types that we could have. We have integers, which could hold positive or negative numbers. We have characters, which could hold a single letter or an ASCII. So let's say I want to know the sex of the user, as a good example. It could either be male, female, some other type, some binary, whatever. Okay? Notice that for characters, I need to surround it by single quotes. If you make it by double quotes, actually, if you make it by, can I change it like this? If you make it by double quotes, it's gonna believe that it's a string and it's gonna break. And you'll notice that when I put my mouse over it, the little red squiggly line which says this is an error, it's gonna tell me I required a character, but you provided a string. So this is bad. Okay? So in this, inside of a character, you could put any ASCII values. ASCII values is, again, if you look at the video, I basically talked to you about how computer is zeros and ones. Well, they take a a bunch of these zeros and ones, and depending on the sequence, they determine that that equals B, A, 1, 3, whatever character. So in here, you could have always a character such as 6, a symbol. All of this is valid. Even space is valid. Cool? Now, what's interesting is inside computers, there is no such thing as spaces or tabs or enter or any of those things, or new line. These are actually just zeros and ones again, and the sequence of that determines what it is that's being shown to the screen to the user, right? So in reality, there is no such thing as spaces or tabs inside the computer. So it's a bunch of zeros and ones together that forms that. So inside character, we could use these things called escape characters. I'm gonna actually put it here. 1 second, escape character. I'm gonna give you all of this at the end, okay? So an escape character is a character that doesn't mean what it sees. So what I mean by this is we could usually have something as in, let's say, T, but if I wanted to have something like a tab, I don't know if you guys know what a tab is. It's basically if I press on the left side of your keyboard, there's a big button that says tab, T-A-B. If I press it, it will move forward by 4 or 5 space, depending on the value set, right? So that is tab. And you could do that by doing backslash to initialize escape sequence, where it will escape the character T and use its other definition, which is tab. So an escape character is used with that, okay, in front of it. So this is important. So you have such as backslash T, which means tab. You have backslash N, which means new line, right? So you could create these things, and actually here, let's do some output here. If I do cout and I use, let's say the sex, and I concatenate it, so I add some other type to it. I'm gonna explain this in a bit. Reza, actually let's say Reza. Again, I'm not creative. You're gonna see me using my name a lot. That's life. Actually, let's make this parental for a second. You'll notice that my Reza is actually being tabbed out forward. You see, this is not a space. Look how, if I select it, it just goes into a big chunk. So this tab is creating this space before Reza, right? And we could do the same thing with new line, right? If I put backslash N, well, now Reza is not going to be on the second line, but on the third line. Cool? And this is cool because with the tab and the new line, we could start creating like a console that looks a bit cleaner, right? And this is something you might want to get into, or actually maybe want to go a bit further and go. So before we had screens and all this, we had these things called ASCII art, and we still do. It's really cool. And what ASCII art is, let's give this one as an example, is writing or drawing with characters. So we could easily copy this and put it somewhere, and we have a frog. So let's say this example could come, and let's go on Slack, and inside random we have a drawing of frogs, but it's all text. And this is really cool. People went further than this, where they said, you know what, we could give it an image, and it's based on that image. Sorry, let me go back one more. Based on that image, I'm gonna make it into a text base. So this is really cool. So let me see if I have an image somewhere. Actually, no, these are examples. Let's go pictures. I have nothing. Let's go on Google. Let's say a celebrity. I don't know. Let's say Justin Bieber. Okay, there we go. We're gonna download. I really don't want to do Justin Bieber. Let's do someone else. You guys have a
Tom Cruise.
Michael Jackson, sir.
okay? I heard
Tom Cruise.
I heard Michael Jackson and Tom Cruise. Oh, it was just either one. So let's say Michael Jackson over here. I'm gonna save the image as whatever. This is web. I want something. 1 second. Save image as. It's all web pp. Let's make it file type png. Just 1 second. Save image as. There we go. Download is fine. Let's go back here. Let's give it the download. If we want to use colors or not, let's not. Let's just do that. And notice that we start getting Michael Jackson drawn to us. And this one is not the best. Actually, what was that? Sorry, give me a second. Let's say use color. Use retro blah blah blah. That's pretty ugly. This website's not the best. But you'll start seeing that there's a lot of websites that will convert your image into there we go. They will convert something that's an image into a text, which is really cool, and it takes a lot of time to this project. And the cool part is I could copy this text and post it anywhere, and it doesn't count as an image, right? And that's really interesting. You notice over here they kind of cheated a bit, where they lowered the font size to be able to do more, and they're using really weird fonts. If we zoom in, notice these are the fonts they're using, or the characters they're using. X, T's, and whatnot, and based on the color they put onto it, you see some art that's being displayed. And this is really cool project to do for yourself. To be honest, as an interviewer, if you did this and showed it to me, I would be impressed. Anyway, moving on. So with the ASCII, you could do a lot of neat things. So we have a couple here: escape characters, tabs, new lines. You have also \0, which is for null. This is done usually inside your arrays. You guys seen that inside C++ a lot. And there's a few other ones. You can look into them yourself. And by the way, guys, if you ever need a break, you let me know. Otherwise, I'm just going to be talking. So let's move on. So we have integers, characters. We have something called a float. So this would be good for, let's say, amount of change you have, money you have, right? So we say 3.34. Now you'll notice that when I do this, I actually get an error. If we put our mouse over it, again, you'll see the error saying required type float, but provided a double. And this is because the default value that we're seeing here is not actually a floating number. So we could specify when we give a number what it is by adding a letter at the end, such as F. And you could do the same thing for D, for double. You could do the same thing for I, for integers, and etc. Depending on the language, it'd be a bit different. So in this case, I'm specifying that this number, 3.34, is a floating number, right? And what is the difference between a float and integer? Well, a floating number is the dot and after, right? This is called a floating number because of this part here. And if you check the video, I'll explain a bit more of that. But you also have this thing called double. So let's say the curve as an example. And what a double will do is it will allow you to be more precise. So in this case, I could go further in my value that's being shown. With float, at some point, oops, this is going on. 1 second. At some point, a float will reach the maximum of floating numbers allowed in the back. It's not giving me an error, but it's certainly not going to be able to show me this. So let's say if I do cout money, let's see how well it's going to show us. You see the limit comes out to 7 values, 7 floating numbers after that, right? If we copy the same number and we add it inside my double, I went too fast. And over here I put my curve. Because double is double the size of a float, you'll also see that the precision is gonna be doubled. Thus the term double. So inside this, a float is usually 4 bytes. And a double, because it doubles the size, it's 8 bytes. And how they divide the whole numbers and the floating numbers, that's something based on them, really. I would really suggest you check out the video. I'll go a bit more precise on how the combination works and all that. I would really like it if I had a whiteboard, because my videos are kind of crap without a whiteboard, but it's fine. Any questions? So it's important to understand when to use one over the other, again, because the box, the variable is this box that could contain a maximum size, and this is really important to understand, because if we lose values like this one, we lost all the other values, our final results could be bad. So let's say if you were working for a financial department or financial company, the precision is really important, because the amount of transactions they do, this mistake that we're missing here, bits and pieces, could come down to millions of dollars, right? So this is what's important about understanding what the type is and how big it is and how we use it. All right, you'll notice also that my variable names are always specific to what it's doing. So we have age, sex, money, curve, all right? And again, this is an example of when you're gonna be doing an application, I do not wanna see A, B, C, and D. If you do something like this, automatic 0 for that assignment. Because our first goal is readability of our code. So the more your variable name is better, the better it's gonna stand out, the better it's gonna be. So while we're at it, you'll notice that, actually I'll put it inside the terms. There is something called a there's something called a convention of writing clean code. And this is over time they notice that when we don't have clean code, it's really hard and it makes your life miserable. So inside this convention, you'll notice something called a Pascal case, a camel case, even sometimes a snake case, right? And this is ways of writing your variables or functions and etc. And inside Java, they use this camel case. So the difference between these three would be this. Pascal case would be uppercase, uppercase first letter for all new words. Camel case would be uppercase starting second word and a forward. So you could see that with this, and you can see that with that. Snake case, on the other hand, it's always going to be lowercase, but it's going to have an underscore, right? Underscore to separate all words. And which one you use, it's up to you. To be honest, I like to have my functions in Pascal case and my variable types into Camel case. Inside Java, right now, the main thing is to always use Camel case for everything. And I would like it that you follow this convention. Why? Because when you go and interview somewhere and they see some other convention being used in their Java, some people are a bit stingy, and whatever stick they got up there, they're gonna get pissed and they're gonna not hire you. Okay? So from now on, you're gonna be using this thing called Camel case. Anyone has any questions on Camel case?
No, sir.
I'm pretty sure you learned it somewhere, but it's nice to know about these three. And you'll notice that a lot of times, depending on the company, they will give you a convention to follow throughout the whole company. Because the code base becomes millions of lines of codes, hundreds of files. It becomes too much if everyone does whatever they feel like. Okay? So adaptation is something really important. Moving on. So we have age, sex, float, double. Can you guys name me something else? I'll take your silence as a big no. So other types, there's a lot of these other types. A few that are interesting for us would be Boolean. Do I understand programming? So notice, because of the uppercase, it becomes more readable than if everything was lowercase. And we want to always initialize this to either true or to false. We could also say the same thing, because this is a 1-bit type of answer. You could also say 1 or 0, and that would be fine, which is the same thing as, actually I'll put it here. Either way works out fine, so this is easily convertible. You have other types such as byte as well, and remember that our integer is 4 bytes and etc. And when you understand the language more, you could do funky stuff, as in shifting the memory, and your values will change, and it'll make your application much more faster. So understanding understanding our computer more will enable you to become a more proficient programmer. But this is for future stuff. So integer, character, float, double, boolean, these are pretty much the basics. These things are called primitive types. So let's put that in here. So actually inside variable, there is a thing called primitive types. So these are the types that exist built in. So it's based on your OS or the Java or whatever software you use. So these are built-in types. Example, int, double, character, boolean, and so forth, so on, and it continues. There's at least like 16 of these. There's a lot of them. Now, string, on the other hand, is not a built-in type. It's someone who made that type. And over this class time, you'll notice we're going to create a lot of these different types. Cool? So notice that when I create a string, it will be a capitalized type. So character, int, float, double, they're all lowercase, while string is a uppercase. So this is good for my name, let's say. You all also will notice that strings will take a double quotes, while characters takes a single quotes. If I put a single quote here, actually we can undo that. If I change this to a single quote, you'll notice again we get an error. Errors comes down underlined. We put our mouse over it. Too many characters in a character literal. So basically says, if you want a character to go in there, it's fine, but you're having 4 characters inside a 1 character place. Right? So that's 1 character, and now we put our mouse over it. It's a different error saying required type is string, but you provided a character. right? And again, we can't have that. We need a double quotes. Now, something to note about string, we're going to talk about it over time because it's really important. We use it a lot of times. A string is not a primitive type. Not primitive type. This is important. You could do funky stuff knowing that. And secondly, it's actually an array of characters. So really, basically, it's this, but a lot of it. That's what an array means, right? So this is the same exact thing, but this is more convenient. So the higher the level of the language, the more convenience we have. And this is one of the conveniences, right? Otherwise, we would need to create an array. So I'll put it in a second. So to create an array, there's multiple ways you could create an array inside Java. So let's say character. You need to put the square brackets. Give it a variable name. So let's say name in characters. And then afterwards, you either give it an initial value for array, or you tell it how big the array could possibly be. Either or. Again, remember that the initialization that we do here is to determine how much memory space it's going to be given to us. With integer, character, float, double, they're really easily figured because int, character, float is always going to be the same size. You might not use all of the space given to you, but it's always going to be the same size. An array, what it says, it's I'm going to give you multiple of that type. So I'm going to give you a lot of character. It could be 1, it could be 0, it could be hundreds of characters. And knowing that character, well, let's say integers, knowing integers are 4 bytes, if I give you 5 integers back to back, well then we know the size is going to be 5 times 4 bytes inside the memory reserved for just that, right? So in this place, we could either start an array, directly give it initial value, and it's going to determine that that's the size of what you need. So this is how we create an array. Curly braces. Each position is given to you and separated by a comma. Notice that the type must match the type mentioned here. I cannot go ahead and put, let's say, a number. Well, actually I could, because it's gonna convert that to ASCII, but it's gonna, let's not go there yet. I can't give it a, let's say, a Boolean as an example, right? So in this case, it's gonna say, hey, I require for my array all of the types to be character, but you provided a Boolean, so this is not acceptable. Okay? Notice that this is the same as this. And again, because we're in a high-level language, it's much more convenient to do a string than to do this shenanigans, which is a lot of pain. So you could initialize it by giving a an array right away. Well, it will determine the size to be 4. And we could have also created this by using the keyword new. So this is basically say, go ahead and create that memory for me, which is a character array of size. The size we're going to give it inside the brackets of size 4. So this is the same thing. Now, the difference though is if we print these two things out, so let's say name and character. By the way, I want to point out something. Notice that my variables in this case are all grayed out. This is the IDE telling you you're never using these variables. Even though you declared them and initialized them, you never use them. The moment we go ahead and we use them, notice that the variable changes color from gray to white. Again, a useful aspect to tell us if we probably didn't use the correct thing or something, right? And then the other one, name, other way. Now if we print this, the last two prints should show us what we did. You'll notice that one of them prints Reza, the other one prints nothing. And this is because even though we gave it the space for it to store characters, the space currently has nothing in there, right? So we have to specify one by one the position. An array, all position starts at 0. There's a big reason for this. This is back in the day where memory was really required. So rather than getting 2 characters, let's say you go from 1 to 9 and then we have 10. 10 takes 2 spots. It was a lot of space. We couldn't waste that much. They started out the numbering system with 0. These days they don't need to do that anymore, but the fact is too many people are used to the old way and they can't just go ahead and change it. A couple times languages tried that, but in the end it failed, and now this is gonna stay forever. So it's a bit of a history. So all positions will always start with 0. So our first position inside our array, which is the big capital R, is gonna be position 0. So in this case, in my new array, which has nothing in there, at position 0, I'm gonna put, let's say, a different character so we see the difference between Reza and, let's say, J. Now if I print it again, you'll notice it's gonna say Reza, and the other one is gonna say J. If we do the same thing, you'll notice first it's giving me a warning. This is what the ID is for. You'll see it on the right side with these yellow things. And on this side, if you put your mouse over it, a variable is already assigned. Sorry guys, it crashed again. So if you put your mouse over it, it should tell you variable is already assigned to this value. So this position 0, there's already a value. Are you sure you want to do this? It sees that we're kind of making a mistake. It doesn't really know. Sometimes we want that, but it's kind of letting us know. So this one's position 1, position 2, position 3, right? Let's add another one and position 4. So let's call this guy Jason, right? Now if we run this, already, if you notice, we have a yellow thing over our number 4, right? If we put our mouse over it, it would tell us, hey, are you sure about this? Because you have a array index out of bounds. So the problem is, we gave it a size of 4, but we start at position 0. So this is 1, 2, 3, 4. This is our 5th element. Even though the position is the same as our size, but because we start at position 0, this cannot exist. So we get this thing called an exception error, and we'll talk about errors in a bit. Does this make sense to everyone? Is there anyone has questions on arrays?
No, sir.
Again, if you guys don't have questions, you could just keep it to the silence, because when you say no, sometimes other people will be kind of, they wouldn't say anything because someone else said no. So if you don't talk, I'll just move on, but you don't need to mention no or anything. So yeah, so this is a problem. So we could either fix this by changing the initial size to 5, or we could erase this. We could always redefine the value of our array. So we could always say, hey, you know what? This equals to a new character array of size 5. But then we lost everything we did in the lines previous. Remember that the computer is stupid. It could only go one line at a time from top to bottom. So it has to do this line before it could go to this line. Before it could go to this line, it has to do this line, right? And it comes down one by one. So at any moment, it can't do a specific line. It can't go to the next thing. It has to finish what it's doing before going to the next step. The only thing is, we believe computers are super strong and amazing because they're so fast. But to be honest, inside our brains, we think of a billion things, while the computer only does one thing at a time, and it cannot go off its script. So you can't do anything else other than what you, the programmer, mentioned. Cool? Actually, I'll leave that. And I'll comment it out. Okay. So that's for arrays. And again, string is basically that too. If we wanted to, just to show you that a string is an array, we could have done name, and you could say character at, which is the function of string, which says give me the, let's say, first character from that string. So now we would see R. And that would be all of our variables. Again, as we go down the line, you'll notice we'll get even more funky, such as this array. Right now, it's a linear array. It has position 0, 1, 2, 3, 4, but we could make it more funky. Sorry guys, it crashed again. We could make it more funky by making it a two-dimensional array, right? And we could just easily do that by adding this. We'll talk about this later, but for now, this is perfectly fine. Yeah. Any questions? So what I would like to do, because my voice is really cracking up, I would like to take a small little break, and we'll continue from this. And today we're gonna go through every little part. So if there's any question, either ask it to me now or after the break, and we'll continue from there. Okay? Any questions? Okay.
So, right, like in the previous subject, we used to take an hour of a break, now and a half an hour, and then at 5:30. So
you used to take an hour, then half an
yeah, an hour of a break. Now it's 3 to 3:30 for half an hour, and then at 5:30 again. There were two breaks.
Okay.
We used to follow that kind of thing. Yeah.
I don't mind however you guys like it. It's your choice. Some classes I never give breaks. Some classes I do. So if you like that, we'll come back and continue at 3:30. And you'll notice later on my lectures are going to be shorter, because this is a review. We're going through everything, and it's going to be a bit long. But yeah, so 3:30 is good for everyone?
Yes.
Yes.
Yes, sir.
Okay.
Yes, sir. Good to go.
Okay, we'll actually come back at 3:35. We'll continue from there, okay? So you get an extra 5 minutes. See you guys then.
All right.